Last time we had looked at direct variation, which is actually a linear relationship between y and x. Today we're going to look at inverse variation. Inverse variation has the form y equals k over x. We would say, if we have this form, that y varies inversely as x, or y is inversely proportional to x. What that means is x goes up, y comes down. Or as x goes down, y goes up. K in this case is the constant of proportionality or the constant of variation. Let's take an example. The time it takes to drive a fixed distance k is inversely proportional to the driving speed. If it takes 5 hours at 40 miles per hour, how long will it take driving at 60 miles per hour? So we have to set up an equation. There is an inverse relationship going on here, and we know the time is inversely proportional to the speed. So t equals k over s. And we now need to plug in some numbers here. So we know the time it takes, 5 hours, equals k divided by the speed, 40. If we solve this for k, we multiply both sides by 40, we'll get k equals 200. So we know our constant k, our fixed distance in this case, is 200 miles, because those are the units we're working on. Now we need to find a solution to the problem. We have our equation. Our equation is t equals k over s, or t equals 200 over s. And it asks us, well, how long will it take if we're driving 60 miles an hour? So if s is 60. So therefore we have to plug 60 in for s. So we'll have t equal 200 divided by 60. And 200 divided by 60 is approximately 3 1/3. And so it will take us 3 1/3 hours to reach our destination going at 60 miles an hour. Let's take another example of inverse variation. Suppose y varies inversely with x. When x equals 2, y is equal to a half. Find k and plot a graph of the relationship. We have an inverse relationship, so we know y is equal to k over x. Now it says when x is 2, y is a half. So we have 1/2 equals k over 2. And if we solve this for k, multiply both sides by 2, we'll see that k is equal to 2 over 2. And 2 over 2 cancel, so k is 1. So k is equal to 1. So therefore my relationship is y equals 1 over x. So this is an inverse relationship, and we will plot a graph of this relationship. So let's take some x and y points. Of course x can't be 0 because you cannot divide by 0. So we'll do x equals 1. We'll have 1 over 1 is 1. If x is 2, we see y is a half. If x is 3, we see y is a third. If x is 4, we see y is a quarter, and so on. So we can now plot this on a graph like this. So we have our points plotted here, but we have to finish off this curve because it looks like we could continue this curve on this side too. So we have to actually put some more values in our table, maybe smaller values of x between 0 and 1 to finish off the curve. So if x is a half, x is a third, x is a quarter, well, 1 divided by a half is 2. 1 divided by a third is 3. 1 divided by a quarter is 4. And so let's plot these points like this. And so we see our graph, the inverse relationship between y and x. And actually this graph here, this relationship where as x goes up, y goes down, is always true of an inverse relationship. Now you might be asking yourself, are there other types of variations? And yes, there are other variations on variations. So let's take a look at some of those.